Welcome viewers. Today we want to look at quadratic graphs and how we can use the given quadratic graphs to find the roots of the quadratic equation. So in part E, we are asked to complete the table below for the function y is equals to 2x squared plus 4x minus 3. Normally a table will be given to you, but I want us to do this together so that we can master our skill in filling the table. What I want you to do, draw a table. I'm going to guide you. Draw a table like the one I have with 8 columns and 4 rows. Draw a table with 8 columns and 4 rows. So we have the columns 1, 2, 3, 4, 5, 6, 7, 8. The rows, these are the rows. So 1, 2, 3, 4. You can easily do that. Or you can even sketch it on a piece of paper. After that, we can start at the top left hand corner. We can write the value of x here. Write the value of x, and then below x write 2x squared, 2x squared, and then after that write 4x and 4x minus 3, and then below 4x minus 3 write y. Now normally the range of the values of x is given. You'll be given the range for the values of x. So in this particular case, our x is greater than or equal to -4, but less than or equal to 2, like that. X is greater than or equal to -4, less than or equal to 2. So these values are included. So after writing that, get -4, -3, -2, -1, 0, 1, and 2, like that. Good. After doing that, we now have to fill in the value of 2x squared. We calculate the values in the second row, and then we shall get the values in the third row, and finally the values in the fourth row. So 2x squared means we get the value of x squared multiplied by 2. So x squared -4 times -4 is +16. +16 multiplied by 2, this gives you 32. Write 32 there. -3 squared, that is +9 times 2, gives you 18. -2 squared is 4. 4 multiplied by 2 gives you 8. -1 squared is 1 multiplied by 2, it gives you 2. 0 squared is 0 multiplied by 2 is 0. 1 squared is 1 multiplied by 2 is 2. 2 squared is 4 multiplied by 2 is 8. That is well done. 4x minus 3. 4 times negative 4 gives you negative 16 minus 3, negative 19. Negative 3 times negative 4, that is negative 12. Negative 12 minus 3, negative 15. Negative 2 times 4, negative 8 minus 3, negative 11. Negative 1 times 4, negative 4 minus 3, negative 7. 0 times 4, 0 minus 3, negative 3. 1 times 4 is 4, 4 minus 3, 1. 2 times 4 is 8, 8 minus 3, 5. Going by our equation, we have y is equals to 2x squared plus 4x minus 3. So the rule of BODMAS applies here because we have evaluated all that. So we shall get addition followed by subtraction. Addition followed by subtraction. So we are going to consider these two columns, the second and the third column, to get the value in the fourth column. So we just add. So positive followed by negative will be a negative 32 minus 19. This gives you 13. And then 18 minus 15, positive 3. 8 minus 11, negative 3. 2 minus 7, negative 5. 0 minus 3, negative 3. 2 plus 1, 3, and 8 plus 5, 13. We now have the table with us, and I just wanted to jog your mind a bit so that we can see how the table is normally generated. In some cases, you'll be given a complete column, one complete column, so that you can start working out from it. So whichever way you want to do it, now you are well versed with that. I already had the table. It's still having the same result as what we have generated. So we go to the second question. On the grid provided, draw the graph of the function y is equals to 2x squared plus 4x minus 3, and then by drawing a suitable straight line, determine the roots of the equation 2x squared plus x minus 5 is equals to 0. So we are going to use a graph paper to do this, but in real sense, in the examination setup, the graph will be printed on the question paper you're going to use. So the most important thing first is to look at the range of the values of x and y. Our minimum value for x is negative 4, and our greatest value is positive 2. For y, the minimum value is negative 5, and the greatest value is positive 13. So on the x-axis, if we pick a scale of 1 centimeter to represent 1 unit, it's going to be a condensed graph, a very small graph. And we want a graph such that it can occupy almost half the page that we are given. So in this case, I opted to use a scale on the x-axis 1 centimeter to represent 1 unit, and on the y-axis 1 centimeter to represent 2 units. So you come at the top right hand corner of your graph paper, you write the scale here, x-axis 1 centimeter to represent 0.5 units, and then on the y-axis 1 centimeter to represent 2 units, like that. After that, get a ruler to draw the Cartesian plane. You get a ruler to draw the Cartesian plane, get a ruler. I'm using my black pen so that I can be able to see what is being done, but for your case you'll have to use a pencil. So you can mark this as the y-axis with an arrow, that is the y-axis, and then we need to determine where the x-axis will fall. So we can start with the greatest value on the y-axis. We say it's going to be 13, so we can start at 14, dropping towards the origin, 14, 12, 10, 8, 6, 4, 2, and then 0. So our x-axis can be drawn there. So we draw again, take the ruler, and we draw our x-axis here. Draw the x-axis. Like that. So after drawing the x-axis, we can label this end with an arrow, and this other end also with an arrow to show that the values are still running. So we can now mark the points. Start here with 0, 1 centimeter to represent half a unit or 0.5 units. So I'll write here positive 1, positive 2, positive 3, and up there on the negative side, negative 1, negative 2, negative 3, and finally negative 4, like that. On the y-axis, I'll write positive 2, 4, 6, 8, 10, 12, 12, and finally 14, like that. On the negative side, I'll write -2, -4, -6, and put an arrow at the bottom here. Now we need just to go back to the points that we obtained and now plot those particular points on the graph paper. So we have the points with us, and we just now need to plot them on the graph paper. So when x is -4, y is 13. When x is -4, right at the end, y is 13. 13 is between 12 and 14. So look at where -4 is. -4 is here, right at the end, and 13 is between 12 and 14. You put a mark here. When x is -3, y is 3. When x is -3, y is 3. When x is -3, y is 3. Put a mark. When x is -2, y is -3. When x is -2, y is -3. So get -2 and -3. Put a mark here. When x is -1, y is -5. When x is -1, y is -5, between -6 and -4. When x is 0, y is -3. Right on the y-axis, put a mark. It's already done. Here, 0, -3. When x is 1, y is 3. When x is 1, y is 3. So 1 and 3. When x is 1, y is 3. So we have 1 here and 3 will be up here. And then when x is 2, y is 13. When x is 2, y is 13. So 2 is here, and then 13 will be up here, between 12 and 14. 2 is here, 2 is here, 13 will be here. Put a mark like that. Now, most of the candidates are fond of using a dot to put a mark. The correct way to mark a point is to put two intersecting lines or a cross, and not doing a bold dot. This is wrong. This is wrong. This is correct. So we must be very, very careful. So this is the way to go about it. Two intersecting lines, not a dot like that. So having plotted those points, we now go back to the graph paper and study the nature of the points. If you look at the topmost point, from the top left-hand corner, we have the second point descending with a smooth curve, descending with a smooth curve and a negative gradient through the bottom of the curve, and then ascending now with a positive gradient. So it is more or less giving us the nature of a U-shaped curve, as I'm showing. So you don't need to use a ruler, that will be wrong. Don't use a ruler to join these points, but use your free hand to draw a smooth curve. Now you are allowed, as I'm doing, you can change or the position of your graph or question paper so that you can be in a position to start joining these points with a lot of ease. Some candidates will try to join them and try to move all their body part with the points as they move. So here we just use our free hand to do this, and we can start go through together this exercise. So I'm starting from that point. You can as well be doing this on your graph paper. Join using a smooth curve. Capture all these points as I'm doing, like that. You can take a break, turn your paper a bit, join through the trough of the curve. I'm now turning my graph paper again. I'm now moving upwards towards the positive gradient, moving up. As you can see, we are moving on very well through almost the last point, and now we are almost done to the last point. So if you look at that curve, it is an appealing curve. It is a smooth U-shaped curve. And then after doing that, you can write, or you should write the equation of the function as y is equals to 2x squared plus 4x minus 3, like that. So we've already plotted that. We can go to the next question. The next question is asking you to draw a suitable straight line to determine the roots of the equation 2x squared plus x minus 5 is equals to 0. Now we have to get the two equations. We have to get the two functions or the two equations. The first equation was given by, or the first function was given by y is equals to 2x squared plus 4x minus 3. And our second equation is given by 2x squared plus x minus 5. So I want to combine these two equations so that I'll start with 0 to be equal to 2x squared plus 2x minus 5. I'll call this equation 1 and this one equation 2. Under a quadratic equation, if we can be able to eliminate the term with x squared, the whole of this term, 2x squared, it means then that the function reduces into a linear equation. What I mean is this: if I eliminate 2x squared here, we are going to get a linear equation. Y is equals to 4x minus 3. And the last question is telling us to draw a straight line. So how do we eliminate, or how do we get a linear equation from these two equations that we have? So we are going to subtract equation 2 from equation 1 so that we can eliminate 2x squared. So when we get it aligned like this, it becomes easier. So y minus 0 gives you y to be equal to 2x squared minus 2x squared. This reduces to 0. It goes to 0. 4x minus x, positive 3x, and then negative 3 minus 5. We're going to have negative 3 minus 5. This changes into a positive sign. So this will be negative 3 plus 5, which becomes positive 2. So y is equals to 3x plus 2. So this is the third and the straight line that is required from us. Okay, so we just now need to get 2 points so that we can plot the straight line. Previously, we have seen how to get 2 coordinates given a linear function. When we want to plot a linear function, we are going to generate a table of values. Right here x and right here y, and 2 columns like that. So when x is equals to 0, we can say when x is equals to 0, substitute 0 here because our linear function now is y is equals to 3x plus 2. So that is our linear function. So substitute the value of 0 here. We are going to get when x is equals to 0, y is equals to 2. Right, 2 there. When x is equals to 1, put 1 here, y will be equal to 5. So we now have 2 points, 0, 2 and 1, 5, 2 coordinate points. We go back to our graph. And plot those 2 coordinate points. We have said when x is equals to 0, y is equals to 2. So when x is equals to 0, y will be equal to 2. Put a mark there. And when x is equals to 1, y will be equal to 5. When x is equals to 1, y will be equal to 5. Put a mark there, like that. And then get your ruler, draw or join these points using a straight line. join them using a straight line. Like that. And then after that, you can as well write the equation of the straight line on the line itself. Y is equals to 3x plus 2. Now we need to get the roots, or to get the roots of the equation 2x squared plus x minus 5 is equals to 0. Now to determine that becomes now easy. What we need to do, we consider where the straight line intersects with our first function. It will intersect at 2 points, one point to the left and the other point to the right. So from the left, we are going to erect a perpendicular just using our ruler onto the x-axis. Take your ruler, draw a straight line onto the x-axis like that, and read off this value. Read off this value here. According to our scale, that value is approximately equal to -2, like that. Come to the other point on the right hand side, using your ruler again, drop a perpendicular to the x-axis, drop a perpendicular to the x-axis from that point, and you read off this value, read off this value here, read off this value. It will be approximately equal to, it lies between 1 and 1.5. It lies between 1 and 1.5. So to get this value, we are going to get 1 plus 1.5, and then all this divided by 2, which gives you 2.5 divided by 2. This is approximately equal to 1.25, 1.25, like that. Therefore, in conclusion, we are going to say that the roots, in conclusion, let me use the graph paper, or we can still use a clear paper. We can say the roots of the equation 2x squared plus x minus 5. X is approximately equal to -2, or x is approximately equal to 1.25, like that. Thank you for watching. Kindly like, subscribe, and share.